Hello. We start with a very short corporate video just to tell you who we are because I think that most of you don't know this name. And then we can come back to the real technical presentation. Okay, so this speech is about the enterprise architecture that we created for Magneti Marelli. As I show you in the video, Magneti Marelli is a very big company, it's a manufacturing company. We build a lot of different kind of part auto, and we are almost in any car that there is on market today with some kind of piece. We are pretty big, we have more than 100 plants all over the world, and is a very real Italian manufacturing company, so a focus on the production and very low focus, I mean, until my arrival in Marelli, on the data part. Data story, big data story for Magneti Marelli started in January 2017 with the creation of the ICT Innovation team. I'm the first hiring of this team. Before me, there was no business intelligence, there was no data warehouse. Anyone care about the data. But our CEO understand the value that today data could bring to a manufacturing company and decide to create this team. So I arrived from a very different industry. I came from fintech, from recommender engine. So for me, manufacturing was a real new world. I spent some time to understand better the business in this first phase that I call the business exploration phase. And after more or less 1 month, I was able to get the money to make the first proof of concept, a very simple proof of concept, just to explain what big data, what machine learning means. Business liked what they see, so they started to give me more money. The team grew. We arrived to a size of more or less 4 people. And we started with the second phase, the proof of concept phase. This phase was concluded at the end of the last year, at the end of 2017, reaching a size of 10 team members. During the last part of 2017, we tried to figure out how to support data scientists and to allow them to work together, to work in a new way. I started with Spark in 2014, and I try out almost any kind of distribution, Cloudera, the one powered by Azure, the one powered by AWS, the Google Data Proc, but no one fits the needs of supporting data scientists to work together. We were pretty desperate because we didn't figure out a way to solve this problem until we saw by chance this new product, Databricks on preview on Azure. And the same day that we see these new products, we try out and I decided, okay, this is our tool. So we started to move all our proof of concept to this new tool. In the meanwhile, we understood that to support data scientists, also an idea of enterprise architecture was needed. So we started to build an architecture over Databricks, and we released this first architecture more or less at April 2018. And then the production phase started because all the proof of concept became a real product. So someone in some plant of Magneti Marelli are using our web application to power their manufacturing and to save a lot of money. And let me say, for free, using architecture, we were able to create all this stuff with a very, very important time to market and without increasing the size of the team because we are still 10 people. So we were able to make more with the same money, with the same effort. From, let me say, the big picture of the data storyline to a very specific process. As I told you, Magneti Marelli make a lot of stuff. The electronics business line is very important. We made the infotainment, the cluster for a lot of machines, for the Porsche, for different car maker. And this was the first big project that we did. And it was about this line that is called the surface mount technology line. Surface mount technology is a process to build the PCB, the electrical board that are behind any kind of electronic device that you can imagine. This process is divided in 3 phases. First, where the pieces are welded on the burrs. Then there is another of preparation, and in the end, the assembly line. It's interesting, I mean, just to make a narrower scope for this presentation because the process is very complicated and we made a lot of application. The focus of this presentation is in the first part of the line, the building one. This part is very interesting because it's very standard as layout. It always has this station. So we have the first station that is called laser marker that is used to laser mark the item ID inside each PCB because we as Magneti Marelli must provide the back traceability to our customer. So if they have any kind of problem, we must understand and we must show to them the fact that this specific board was done in the correct way. Then there is the serigraphy, where the soldering paste is poured on the board. There is the 2 different computer vision stations. There is the pick and place, that is a machine that, is very simple. Just pick components or resistor capacitors and place this component in the right spot. There is the oven to stabilize the soldering. And here comes the pain, because each of these machines have its own logging technique and strategy. Some machines have some kind of application log, so we rely on the craziness of the firmware developer. Other machine has some kind of database, more structure, and for us was a big problem. We had 6 machines with 6 different operating systems, from Windows NT to Windows Vista. We have 1 Windows Server, 1 Windows 7, 1 Windows 8. It was very, very complicated situation. The focus of this presentation is even narrower, it's just about the pick and place. We started from pick and place because this data was in a SQL database, so it was easier to us to manage this data. Starting from this data, speaking with the field engineer, it came out that there was some very simple use cases, some very complicated use cases. So the machine status monitoring for them was a killer application because they didn't have this kind of capability before this project. The second part, interesting, was the study of the bottleneck because in any production line, there is a machine that is lower than the other that is called bottleneck, and a lot of statistics are done on this specific machine. What we discover is that this bottleneck sometimes vary over time, because if there is some kind of problem, it's possible that the bottleneck become another machine. In the end, there is the Anomaly recommender engine. What is the problem? We started with no data, no knowledge, no information about the line, and we arrived with tons of information, tons of dashboard, of anomalies, of alerting, and for them was worse because they didn't get how to manage all this knowledge. So we create this recommender system that was able to expose just a subset of information. This project started as a dream project because the production process is well known, because the data source is clearly defined. We know that exists a database with this data. This need is raised by the plant people itself, so there was a full commitment of field engineer, of the plant manager, of machine leaders, of everyone. And in the end, from the algorithmical point of view, the challenge was pretty clear and pretty easy. We are not talking about rocket science. It was just analyzing series of data and create simple or complex machine learning models. But this very dreamful project became a nightmare because between these premises and the success, there is the data scientist. Now, this presentation perfectly fit with the Italian market. I don't know if in UK or US is the same, but in Italian market, data scientists are very, very strong on the algorithmical part, on the statisticians. They are very, very skilled, but they lack on the traditional IT skills. So dealing with database, understanding what is a microservice, what is an architecture, what is a singleton, are kind of knowledge that today data scientists don't have. There are some few unicorn data scientists, and I'm sure all of you are unicorn data scientists, but I have the luck to meet just one data scientist on 10 people. So I had to deal with the team that I had to finish the process. And this is where the idea of architecture burns. Obviously, this is a joke, this is not architecture, but sometimes I saw this kind of incredible presentation with the checklist of technologies. Our architecture followed this principle that was created by US Navy in the 1960s, that is, keep it simple, stupid. There is no reason to make something complex if you can have the same output with something that is very simple. This is our architecture. Very few services, a real effort on the integration of these services and on some architectural objects custom-made to support data scientists. And through this architecture, I'm trying to explain how we support data scientists answering their questions. The first question is, data, where are you? I mean, in a plan, there is a huge complexity, and having the capability just to extract data from a database is complicated. No one knows what is a BCP out procedures, so they will use a select star. That means killing the database and create is crazy. Or, okay, I have this data, how to move this to the cloud when the firewall is in the middle. It's very complicated. A team of architectural experts spends a lot of week to deal out with this problem. And this kind of problem are too much for a data scientist. More or less, this is the scenario that I saw in my working life. So the 90% of the time, there is the quick and dirty solution. Give me the USB key with the data, and I'll think one day how to create something that works for real. It's not just a fake demo. In the other 10% of cases, some data scientists try to solve this problem, but this is not a real data science problem. So they didn't have the real knowledge on some more traditional IT stuff. And this is why we decided to invest a lot of effort to create a very complicated structure on the data lake. Not complicated, it's very simple, but it's based on a lot of choices to optimize our processes. So we have a double index on data lake that allow us to read data in a very effective way. And then we developed this tool that we call Hammer Gateway. And today in Magneti Marelli, you can ask for the Hammer Gateway, and people know what it is. I saw this Hammer Gateway on some Accenture presentation, so it's something. I mean, when you give a name to something, it starts to exist for real. And this was happened with Hammer Gateway. The Hammer Gateway, as the name saying, is just a gateway to solve the firewall problem. So it's on a DMZ zone to move the data from the internal of the plant to the cloud. And it is an hammer, so he is very stupid. He has no caching logic. He just takes the data. He's able to deal with the incrementality with some trick that we put in place. So it's stateless. It means that if they shut down the machines, and sometimes they do this, when the machine is already powered on, the hammer starts from the point that if he was interrupted before. So it's a very, very simple component. But we put all the complexity of the ingestion on this very simple tool. Okay, we have the data on the cloud. The second part is what I call the Jupyter case. I mean, I love Jupyter. But Jupyter brings with himself a lot of technical skills that you need to have to understand for real. Because, for example, how to attach a Spark cluster to a Jupyter if you are not using a Docker with always preset is not so simple. Try to attach, for example, Google Cloud Dataproc to a cluster. To a Jupyter notebook. It's so complicated that in 2015, Google released a snippet of code to make this for you because it was very, very complicated. Also dealing with other very technical problems like Java heap memory exception, or like when you first the shutdown of Spark, and then the disk of the machine is full of data that is inconsistent. This kind of light architecture is the one that is the most quick and dirty and easy. And if you know what you're doing, is a very good architecture, so Apache Spark, Docker, Jupyter Hub, but it requires that you really know what you're doing. For this reason, we decide, first of all, to use Databricks, because Databricks solve almost any problem on the left side of the slide, because really accelerate our time to market. And we decided to write this object that we call MCO. What is the MCO? MCO is a very stupid singleton that take inside all the tokens needed. And this is a choice that we made to solve a very simple problem: how to share the key to access the data lake with all the data scientists. I know that you can do this using the secret of the Databricks, but what if we decide to change the data lake and create another Azure Data Lake? You have to go manually on each notebook and update this information. It's very, very boring, while using this is a way to centralize all this complexity. This MCO is very stupid and allow you to do just 3 very simple things: read, write, and log. The first part is why data scientists need to know the complexity behind the data lake and the structure that we created. They just need to know the name of the data. And for example, if they need just a subset of the data of the last 2 months, there is no need that they load all the data and then make a filter on Databricks. It's easier if we try to hide this complexity. The same reason are behind MCO.write, because writing is even more dangerous than reading. So there is no reason to give them a chance to make some kind of error. In the end, there is the logging problem. Almost any data scientist that I saw use the print Python function to log their application, and it's not the right way to do. I just said, okay, guys, you have this mco.log.write is the same as print. Please use it. And in the meanwhile, I'm writing the same code on a technical database, so I forcing them to log like a real developer without even know it, and it works pretty well. The model is ready, the exploration has finished. For the data scientist comes the pain, because there is the panic of going to production. And also for this reason, we try to create some architectural object to support them. These 2 main components are the message queue and the forwarder. Probably when I said message queue, you are taught about Apache Kafka, some kind of stuff, but it's not the case. The message queue is just a list of services with 3 attributes: the name of the service, the status of the service that could be to do, done, or in progress, and the application server. So everything pretty easy. The forwarder takes the first service, it submits to an application server. Through the MCO, it takes the data, it applies the logic, and it saves some kind of view or what is needed on the data mart, and then it takes the second service. And I mean, here is not anything special, this forwarder, but this forwarder allows you some kind of trick. The first trick is, imagine that we have a super secret service, and this data cannot leave Magneti Marelli for any reason. It's not a problem, because the forwarder becomes the first idea of hybridization. What does it mean? It means that the forwarder could submit the same logic on an on-premise Apache Spark cluster, and using the MCO, this cluster takes the data from an enterprise data warehouse and then persists the data on an enterprise data mart. The funny part is that for the data scientist is the same, because he don't know where are data. So it's very, very tricky, but very, very effective. The second part that could be an interesting use of the forwarder is the multi-queue problem. What if we have a very long service that takes a lot of RAM, and we need to run a very urgent service that maybe is a spike of RAM and duration? for this reason, the forwarder is able to create different replication of the application server. I know that with Databricks you can scale out of the box, and this is very powerful, but if you need to separate and if you have something that is very urgent, waiting that Databricks rebalance all the machines on the cluster is a waste of time. In the end, there is the presentation layer, because obviously the business, I mean, who cares about forwarder and Singleton and this pattern? And I mean, this is even trickier for a data scientist, because the front end is very complicated and because it's very far from the data scientist world. And I mean, the only solution that I found for my life is starting to study the web development part, because it's very complicated. We decided to use PowerBI because PowerBI is, for this kind of trick, is amazing. We give to data scientists the capability to create real application with some limitation, because obviously PowerBI is not a presentation layer. A real presentation layer is a BI tool. We use it just to connect to database, to data mart, to create in a very fast way widgets. And this way, data scientists are able to make the full production stack by themselves, and it was very, very successful. So, I mean, to recap all this part, this architecture was a real game changer to us, because we removed the complexity of data ingestion, because architecture embeds the guideline. No one in Marelli is able to read data if not using MCO. So no one can make crazy stuff, can load it. No. To read data, you have to follow the MCO. The presentation layer is both drag and drop, but we also have the possibility to create real web app with ASP.NET and Bootstrap. And the enterprise part of the production is well written, and the data scientists could focus just on models. And this is what transformed the nightmare project back to a dream project, because with this architecture, we were able to make a lot of things very, very fast. So, coming back with the original problem, I'm going to focus just on the Anomaly recommender engine for a question of time. And I mean, we created this dashboard that is able to lead the maintenance team. So they have all the problems that are on the line of a given plant, and we make like a funnel to force them to focus on a specific line. And we create a machine learning-based scoring function that is able to rank the most anomalous event and situation to support them. And I mean, why I said that it was a very successful project. First of all, we reached the break-even in just 8 months. This was thanks to both Databricks and PowerBI, because with these two tactical choices, we have a time to market that was impressive. After 1 month, we have the first application running for real, not in real time, in a batch time, but it was running. We were able to reduce the cost by 90% for any lines after the first one, and the return on investment of the spreading out of this project on all the SMT lines of Magneti Marelli was about 12 times in 3 years. This was thanks the Hammer Gateway that solved the ingestion problem, the MCO, because using this, we are reducing the complexity for data scientists, and we are able to pour their code in production in a couple of days. In 5 days, 10 days, we take a proof of concept, and we transform to a real production service. And in the end, obviously, the power of the Azure cloud and the Databricks allow us with the scalability, solving all the technical problems that we don't like to, is not a added value phase. This is the team behind this project. I had the chance to work with very skilled people, Florindo, Giovanni, Alessandro, and Manuela, and we built this part, they built this part. I was just the master of slides of PowerPoint. I'm not really involved in this part. They built this architecture in a couple of months. They make a wonderful work, and it was thanks to a very important supporter, because the main supporter was Mr. Schering, the CEO of electronics, a very important business line, and our other big sponsor was Dario Castello, the CEO of Magneti Marelli, who support us in all this development. Thank you.